Hey there, this is your statistics practice chapter 2. I want to show you how to find that. So if you go to you log into your Canvas account and you go to modules to find a chapter 2 practice test. Hit chapter 2, and at the bottom is going to be the chapter 2. It's part of exam 1, but it's the chapter 2 practice exam. And I'm going to go ahead and start here. So we have a frequency distribution table here, and this is the cell of home prices, and they want to know the width of each class. So let me switch to my other camera. So the class width is the difference between the lower limits. So for number 1, I'm going to go 110.0 minus 80.0, which is going to give me 31. A very common mistake is to subtract the 110 minus the 80 to get the class size. That is not the class size. Class size is the difference between any two lower limits or any two upper limits, to be honest with you. Let's move on to number 2. Frequency distribution below, same idea. They want to know the class midpoint for 235 and 265 for that class. Let's switch here. So for number 2, they want to know the class midpoint for 35.0 to 265.9. And the way you figure that out is I take the difference between the two, or I'm sorry, I add up the two and divide by 2. Basically, I'm finding the mean of the class. So 235 plus 265.9 divided by 2. And that gives me the 250.45. Now this looks like 235 minus that. That's not what this is. This is a class, as we're looking at that. Number 3, frequency distribution, same idea. They want to find the class boundaries. Now this one's going to be just a little bit different than the way I showed it in the left. I'm going to write this down. So between 80.0 and 110.9. And what's different about this one, in the previous one that I did in class, what I said was add and subtract 0.5, but we're already in the decimals. So we need to add and subtract 0.05, meaning 80 minus 0.05. That is going to be my lower class boundary. $110.9 plus 0.05 in this case. You always go one more decimal out. $110.95. So here are the class boundaries. So for number 4, we're going to construct a cumulative distribution. Now, for the heights, we do this a little bit differently with the cumulative, and I will show you how we set this up. So for this one, I'm going to set up this is the cumulative frequency. And for this, it's going to be less than 72. Next one is less than 75. Next one is less than 78. Less than 81. And the last one and the amount of frequencies that are less than 70 is here, is the 16. So in this column here, my first column, I'm going to put 16. I'll switch the camera here in just a second, 16. But in the next one, less than 75, you can see right here, here's 75. So less than 75, that's going to be 22 plus 16. So 16 goes here, and here we have 22 plus 16, which gives me 38. You don't need to put the plus in there. I'm doing that just to demonstrate to you where I'm getting these numbers from. Now, less than 78 is going to be the 15 plus the 22 plus the 16. This gives me 53. Next up, 1 is going to be the 14 plus 15 plus 22 plus 16. And lastly, this is everybody, 13 plus 14, 15 plus 22 plus 16. Gives us to 80. That's how you do a cumulative frequency distribution table. Next up, we have number 5. And here we have a frequency distribution for weekly incomes of students with part-time jobs. And we're going to construct a relative frequency distribution. Relative means that we're going to have percents as we look at this. So I'm going to switch back and fill this in. Oh, here we are at 5. And here we'll have relative frequency. And I'll be writing these in percent. This part's the same. And here we have the original one had, and I'm just going to lightly mark this over here, had 55, 70, 73, 68, and 10. This is the regular frequency distribution. That's in the actual problem 5. Now what I'm going to do is I'm going to total all those. I need the total, and that'll serve as my denominator. 55 plus 70 plus 3 plus 68 plus 10 gives me a total of 6. And that's going to serve as my denominator. So to find my relative frequency, I'm going to take 55 and put that over the 276. And I'm going to divide that out. And I'm going to write that in percent form. Nearest hundredth of a percent. So this is going to be 19.93%. Remember, you have to move the decimal over twice, or times 100. Excuse me. Next up, I'm going to take 70 over the 276. And that's going to give me 25.36%. Next up, we have 73 over 276. $26.45 if I round that off right. You, of course, should be verifying all these numbers with your calculator. Make sure that I'm getting them correct. Because I make mistakes too. Next up, I have 68 over the 276. It's 24.64 if I round that off right. And last but not least, we have 10 over 276. This is going to be a smaller percent. 10 divided by 276. So that'll be 3.62%. Now, in theory, if we were to add this up, it should be 100%, but because of round off error, it may not exactly be 100%. You can certainly double check that. Let's flip the page here and move on to number 6. Excuse me. Number 6, I'm going to flip back so you can see it. So here's number 6. We're going to construct a frequency distribution. I'm going to change this one slightly. Instead of 4 classes and starting with a lower limit of 60, I'm going to start with the way that I showed you guys, which is the smallest number first. I've actually already put these numbers into my calculator, and I want to remind you how you can sort them in order to make it easier for you to see them. So this is number 6. And as promised, I put these. So you hit stat, and I'm going to edit a list. Here's my list 1. And you can see it's 9171 if you have it in front of you, the sheet. So I put all the scores in there, and they are not in the right order. So what I'm going to do is I'm going to put them into the right order. Refresh your memory how to do that. You're going to hit stat. This is with an 83 or an 84. We're going to go to sort A. And I put my information into list 1. So moving on with number 6 here. Once again, I wanted to show you in my calculator. I put the data into list 1, and I want to sort it now. So now I'm going to go to stat, sort A, and I want to put it in to list 1. Now list 1 is right above the 1 button, but mine's blue, so I got to hit the blue button first, then that. And that will sort it in A ascending order versus the D, which is descending order, meaning biggest to smallest. So we want smallest to biggest. So now I can go here and I can see it's changed the order. So now everything's in order here. And I'm going to start my lower bound with the 66 instead of the 60, like they asked me to do. So we have score and frequency. And they want 4 classes. And the way we find the class width, when we have raw data, is I take the largest, so the max, minus the min, divided by the number of classes, which is 4 in this case. So my largest number that I have in list 1, if I hit up, it goes to the bottom, is 91. Minus the minimum number, which is 66, divided by 4. Because there are 4 classes in this one. So 91 minus 66 equals divided by 4. So this goes to 6.25. But when it comes to class size, we always want to round up. So our class width is going to be 7. And as I mentioned, I'm going to use the data that's here instead of starting at 60 like they asked me to do. So my table is going to look slightly different than the table that's in the answer key. So I'm going to start with the lowest value, which is 66. Good, 66. And I'm going to get the next lower limit by adding 7. So 66 plus 7, 66 plus 7, 73. Now I'm going to add 7 again. Gives me 80. Plus 7 again. 87. And there are my 4 classes. Now these are the lower class limits. How do we find the upper class limits? Well, if the lower is 73, that means the upper for the previous one is going to be 72. If the lower is 80, that means the upper of the previous is going to be 79. Now you can see it's also adding 7 each time. So to get this one, this is going to be 86. And to get the last one, I'm just going to add 7 to the 86. So you'll notice I'm just adding 7 each time. So 86 plus 7 is the 93. All right, let's go to the frequency now. Another advantage of being able to rewrite the list in order is we can now see how many of them are between 66 and 72. So it looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 it looks like. Now between 73 and 79, looks like we have 1, 2, 3, 4, 5, 6, 6. Now between 80 and 86, I have 1, 2, 3, 4. That's an 87, so no, so 4. In between 87 and 93, that's 1, 2, 3, 4, 5, 5. And there it is, your frequency distribution table. Again, it's going to look slightly different than the answer the answer key does because I started at 60 and 66 instead of 60. All right, let's move on to number 7 here. All right. So we're going to draw a histogram based on this data here, which means we're going to have to set up another table. And once again, I have previously entered all of this data into my calculator so that you didn't have to watch me do that, but you can certainly do that on your own. Let's push this up. Excuse me. All right, so again, I've entered the data. Mine's in list 2 now. I'm going to sort it also. So I'm going to stat sort. Again, list 2 is above the number 2. Second L2. Now I'm going to go back to my list. And you can see it's now in order. And this one, they did say that they want construct a histogram and what is the approximate age at the center. Okay, we'll get to that. So to do the histogram, it wants a lower class boundary. So they give us a class width of 10. I only want us to start at 20. That's okay, we can do it their way this time. So this is going to be age. So ages. And this is frequency. So 20 to 29. They tell us the class width is 10. 30 to 39. 40 to 49. 50 to 59. And I'm looking at the data, and I can look here to see what the largest is. I think it only goes up to the 60s, into the 60s. So that'll be our last. And let's see what the frequency of that is. So between 20 and 20, so in their 20s, we have, it looks like 2. In their 30s, it looks like we have 1, 2, 3, 4. And in the 40s, looks like we have 1, 2, 3, 4, 5, 6, 6. In their 50s, we have 1, 2, 3, 4, 5, 6, 6. And we have in their 60s, 1, 2, 3, 4, 5, 6, 7, 8. So to be clear, our boundaries are going to be the 0.5. I should use different color. Let's use green instead. 19.5 to 29.5, 29.5, 39.5, and so on. So here we go. Looks like we have 1, 2, 3, 4, 5 classes. So 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to do here 19.5, 29.5, 39.5, 49.5, 59.5, and 69.5. And these are the frequency. So for here, we're going up to 2. for here, yeah, 29 to, yeah, we're going up to 4. Ooh, a little crooked there. Next up, we're going up to 6. Next one is also 6. Leaning Tower of Pisa there. And then here we're going up to 8. That's the best you're going to get out of me, unfortunately. So that is number 7. Let's move on to 8. Here they want us to use the midpoints for the horizontal scale, which is fine. And they already have the distribution table set up for us, which is nice. So I can see that the midpoints here, midpoint here is going to be 1, 4, 7, 10, 13, and it looks like 16. All right, let's see if I can squeeze this in there. Switch back. This is number 8. So we can squeeze this in here. And they say use class midpoints. That's easy. Does this appear to be a normal distribution? Why or why not? So this histogram are not going to be touching one another. And just to point out, this one is definitely not normal, right? It's getting bigger and bigger and bigger. So we'll see. So 6, 7, 8, 9, 10. And here I'm going to have 0, 1, 2. I'm sorry, 1 is the midpoint, 4 is the next midpoint, 4, and then 7, and then 10, and then 13, and then 16. So again, these will not be touching one another. So for a midpoint of days off is 1, we're going all the way up to 10. Wow. For 4, we only have 1. For 7, we're going up to 7. 7's here. Should probably be using a ruler. Next one is also 7. Next one is 1 again. And 4. 4, 1, 2, 3, 4. You can do a better job than I did. All right. Let's take a look at number 9. Number 9 is here. So we have these next bunch are going to be the same. It's just they're asking different questions. They want to know what class width was used to construct this. Well, we can see down here that that width is going to be 10. Right, they're going up by 10 each time. So the answer to number 9 is 10. I don't need to write down. Number 9 is 10. That's why. Next one, same information. And they want to know what percentage of these people had a reading between 110 and 139. So here's 110. to basically to 140. So basically what we're going to want to do is add up 0.35 plus 0.25 plus 0.15, and that'll give me my total. So once again, the answer for 9 was 10. For number 10, what I need to do is add up 0.13, pardon me, 0.35 plus 0.25 plus 0.15. Mixed up the word a little there, but it won't matter. 0.75. So they want to know what percent. So this is going to be 0.75, which means the answer is 75%. All right. This one, same information. They want to identify the center of the third class. So here's the first class, second class, third class. And what's the center going to be? Well, all I'm going to do is take the mean. 120 plus 130 divided by 2, that's going to give me 125. Oh, I didn't switch it, sorry. So here we have our third class. So first class, second class, third class. And again, the middle is going to be the 125. Now I'll switch back. So this is going to give me 120 plus 130 divided by 2. This is 120. And as for the last one, this one got weirdly cut off. I was asked in class a little bit about it. We're going to say that this top part ends at 50, even though it looks like it goes higher, but I'm going to call that 50. So this is going to be 20 plus 50 plus 15 plus 10 plus 5. So let's switch over. So for 12, that's going to be 20, because they want to know the total number of households that are included here. 20 people plus, I said we'll make that 50 people, plus 15, plus 10, plus 10, yeah, plus 5. +20 plus 50 plus 15 plus 10 plus 5. 100. One thing I realized I just missed out on, they wanted to know if this graph looks like it's normally distributed. This is back to number 8. And the answer is no, it's definitely not normally distributed. If it was, it would start low and it would get big and then small again. And it's definitely not doing that. Thanks for listening. Hope that helped.